Welcome everyone. This is video number 6 in a series based on my book Learn Harmony v3 for PIC32MZ. In the last video, number 5, I showed you how to add the USB library to the project and use the Communications Device Class CDC function to add 2 COM ports to the project. In this video, we will add and configure the TCP/IP library to the project. As a reminder, all of the custom source code used in these videos is available from GitHub. If you have not already downloaded the file learn hv3_figures.txt, do it now. Before we continue, I want to give you some information about the TCP library that's included with Harmony. As you can see on this slide, it's quite complicated. These things have to fit together, and if you don't get them right or the configuration's wrong, it won't work. So one way to understand this a little better is to use the idea of the stack, and they use the TCP layer stack starting at the bottom: network interface, the internet, which includes some of the basic ICMPv4, and we go to the transport layer, and finally the application presentation layer. So in order to do anything with TCP/IP, you're going to need all of these layers that have to work together. So it's not something that you just look at and say, oh yeah, I understand. It takes a little bit of study and work, but it does work amazingly. So let's go on. So this is what we're going to be doing in this video. We're going to add the whole library to the software components. We'll clone the previous project so we have a nice clean starting point, and we'll add the basic library, TCP/IP library components, and then configure them. We'll also create a new state machine that handles the basic component that the stack requires. And again, just like we did before, we'll create a new header file, call it stack.h, a new source file, and then update the app.h and app.c file, just like we did for the USB library. Okay, now it's time to download the TCP library. So open the MPLabX IDE. Go here to Tools, Embedded, Content Manager, and go to the connection. Okay, so now we have to just find things related to the net. We are going to need the crypto library. We are going to need zlib. Sorry. So back into the core, crypto, and 2 more. The net package, and down here at the bottom is going to be a wolf. Keep going. Don't give up. There it is, Wolf SSL. Okay. Download the selected ones and automatically mark them for download. No, cancel that. We're doing them by hand. Accept all licenses. Next, next, next. Close. Okay, so now they're starting, so we can see each of them. There's the everything's there. So yep, there's zlib. There's crypto. There's the net, the Wolf SSL, and they're all synchronized. So we can close this. And we're ready to open a project and add the pieces to the project. Okay, now we're going to clone the previous project and create a nice clean starting point for the TCP IP library project. So we'll go down here in Applications, Microchip, Harmony v3 apps, and there's the previous one. We'll just duplicate that, just copy it, and then rename that to, let's call it layers. Okay. And under layers, you'll see that the old name is still there. So we'll take MPLabX will take care of that. So let's open MPLabX, open the project, go up, back up here to layers, firmware, and there's the old name.x file, which you have to open. And right click on the project name here, do the rename function, rename it to the same name as the file, layers, and hit rename. It regenerates all the make files and stuff like that, and then does some parsing down here. So when that's complete, we have entirely new, clean project. Okay, we're ready now to add the software components that you will need for a typical TCP/IP application. So down here, let's just start from the top, and we'll be adding like 19 software components. So we'll need some drivers, Mac driver, internal ETH/Mac, MIM driver, we'll need a PHY driver. We use 8740 on the dev board. And forget Harmony networking, that's obsolete, so we'll head into the libraries. We'll need the crypto library. Under core, we'll need netconfig, TCP/IP core, ARP, ICMPv4, IPv4, transport layer, we'll need TCP, yes, and yes. Does some of the automatic connections, which we could make manually. Layer 6, presentation layer, yes. Layer 7, announce. DHCP client, DNS client, SNTP. Okay. I do not recommend use these configurators. They add a lot of confusion to the project graph. They add extra views up here so you can't find anything. I kind of like to see everything in one place. So, and we'll go to third-party libraries. We'll need the zlib library and the wolf SSL library. So let's verify we got them all. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Good. Now we need to do all the connections. So we got a red connection here on the Mac layer. It has to be connected to something on the PHY layer, which would be over here, the 8740. Looks that way. And this goes down here, and let's get rid of crypto library. Rearrange these things a little bit. Mac has to go to net config. Okay. Okay. And we have the zlib library over here. It needs to be hooked. That one. Okay. I think we've got all the connections. TLS provider isn't connected because we're not doing any HTTPS stuff yet. So I think we've got everything else. And all of these will be using the default configuration, except we want to switch this one, the heap configuration, to the external heap, so we don't have to worry about how big the internal heap is. Just to show you how easy it is to make changes to these settings if you know what to do with them. Okay, so we're all set to go. We go up here to let Harmony generate all its code. So generate the code, generate, and okay, offline I cleaned up the project graph a little bit, so it was a little cleaner. It didn't change anything. Now what we have to do is adjust a few things for our application. First thing is related to a slight bug in the MHC. When it generates the code, there's a file missing, and I think it's only missing when you do what I did here manually. If you use these configurators, for whatever reason, the file exists. So just in case it's missing, I'll show you what to look for and how to fix it. What we're looking for here, notice in the header files of the project, there's in the header file config PIC32MZ, go down here in the system folder. There are two files, sysrandom h2 adapter and systime h2 adapter. That's in the header file. So you'd expect in the source files, go down to source files, config PIC32MZ, under system. You see there's only one. The sysrandom h2 adapter.c is missing. And if you were to compile and load this, you'll get a load error at that point. So what we need to do is add it from the net repository where it gets its stuff from. So we're going to add an existing item, and what we need to do is go up to the source file we need to go all the way up to the v3 folder and go down to the net folder. This is where the repository is copied from the GitHub. And we'll go down here to sysadapter, and there is the file that we're missing, sysrandom h2 adapter.c. We've already got the H file, and there are the time ones, so that's the right place. So we select it, and it gets added to the project. Okay, so that's one problem we've fixed. If this file is in your source system directory, you don't have to do anything, just go on. All right, so now we need to fix two other problems. One that are related to the log messages, where we're trying to capture all the log message from the MHC generated code and our own code. So there's a problem here in the TCP/IP manager.c that it doesn't include the app.h file, which has all the macros. So let's add that. By hand. Okay. Get that one. And the initialization.c file down at the bottom, where it does all the system initialization, and near the end it does the app initialize. Well, if we're going to get the messages that occur up here in the system files, we've got to initialize our log messages routine, so we have to move this up to the top, comment it out here, and move it up right there. Got the comment. Okay, so now that gets initialized before all the system stuff, and that should be fine. So, but we made changes to the generated code, so we have to generate code again, and you'll see all this, how this shows up, and also shows how, if you're making changes to any of the code and then regenerate the code, MHC will give you a merge file to allow you to accept or decline the changes that were made. So, give this a chance. There it is. So here we are, TCP manager.c, and there's the include file. That it says what this is saying is, if you don't want to change, it'll blank it out. This is the file that we want, so we'll close that. And there's initialization.c. There's two changes, the one we want, and there's the other one. So that file looks good. We don't want to change it, so let that go. So if you make changes in the future to any other files, you'll get these merge screens. So you just close them if you want the changes. So, okay, so now next step is to add our custom code. We're done with all the MHC code. Time for our custom code. All right, now we're going to add our custom code as a new state machine. So we'll need a header file, need to add a header file and a source file to the project. Right click on header files, new header. We're going to call it stack. Okay. Source files, new x32.c file. Call that stack. It is. Okay, so now we'll go to each one, select all, delete it. I'm doing this, blank out these files. We have two blank files. Now we'll add from our learn HV3 figures.txt, we'll fill these with correct code here. So the H file, Control C, Control V, C file, here, scroll down here, pick up. And Control V that. Okay, we've got all our custom code in. Now I just have to make sure we add the new state machine to the project. All the proper stuff gets in there. Just a little stack.h and app.c. To add the initialize. As I just used the same formatting here for the various state machines, so I don't forget what I've done here. So they all, with the name initialized, name SM. That's just, they can be anything you want. Okay, so now we've got everything in there. We're going to check to see how it clean and build the project. And if this builds correctly, then we can download it to the device and do a quick test. So this may take a while, so we'll come back to it after it's completed. Okay, here we have it. Build was successful. Now let's download and test the program. Use the green down arrow. Boom, that's how fast it is. Go back here and see. Yeah, so it erased it. Rang verify complete. That's great. Okay, so now to test it, let's go to a terminal session and ping the static address. There. So that ping works. Let's go to our CoolTerm and connect it. This is our, oops, that's not the right one. To get the connection. Okay. This one. And connect that. Okay, and here are all the log messages that were generated since we started the board. Initialization started, we had the timer, and initialization ended with success. These errors, or these messages, were created in the initialization of the stack before we actually got the log messages service going, and so that's why we had to add that, make a couple of modifications to the MHC generated code. But anyway, once the initialization was complete, then it initially shows the change in the TCP or IP address, which is 0. Then it comes back 12 seconds later. Notice that it took to get to the correct static address. In previous in the book, I believe this time difference is 4 seconds. Well, there must be some setting there that makes this thing wait a little longer, but that's the advantage of having the time tag on here. If this is important, you could trace it down, but it's not important at this moment, so we'll just leave it, knowing that from the time it started up till at this point is 12 seconds. So that's about it. Project is working completely, so we'll add more to it in the next video. Okay, now we're at the end. We've done all this stuff, so congratulations. You've just created and executed a Harmony project that uses the basic components of the TCP/IP library. In the next video, I will show you how to create a TCP or UDP client or server using the Harmony TCP/IP library. Okay, so remember to hit the subscribe button. Thank you for watching, and I'll see you in video number 7.